Now, so far this has been very intuitive. I haven't actually showed you a specific method, so let's think about what we're actually doing. So if I asked you to differentiate something like 5x to the 7, we bring the power to the front and multiply, and then we decrease this power by 1. So we would end up with bring the power to the front, decrease power by 1, and then simplify this expression here, 35x to the 6. Now if we're going to integrate, we're going to do the reverse of that. So we're going to go back up this list here. So we're going to increase the power by 1. So x to the 6 would be x to the 7. And then we're going to, instead of multiplying by the power, we're going to divide by the power. So if we look over here, if we start off with this question and work out the integral of it, we're going to increase the power by 1. And then we're going to divide by the new power. So if I do both of those things then, instead of having 6, if I increase that by 1, that gives me 7. Divide by the power, so the new power is 7. So we divide by 7. Also, we've got to remember to put plus c on this as well. And then we go ahead and simplify. So 35 divided by 7 is 5. And we are indeed back to where we started from. Now, you can also check your answer for these questions as well. So you should never know if you made a mistake or not. So if we bring the power to the front here, we've got 7 times 5. Decrease the power by 1, which is 6. 7 times 5 is 35. And sure enough, it's exactly what we thought it was. So that's a nice little check that you can use to make sure that you have integrated correctly. In general, this is what we're actually doing. For any expression here, we're increasing the power by 1 from what it was before, so n goes to n plus 1, and then we're going to divide by that new exponent, so that's why it says n plus 1 here as well. It's the same as what the exponent is up here. And then don't forget to put plus c on the end. So if we look at a couple of specific examples here, if I was looking at 5x cubed, I would say I'm going to add 1 to the power, and I'm going to divide by that same number. So really, you're just going to do this. You're going to say 3 plus 1 is 4, and then I'm going to divide by that same exponent plus c. We can get more complicated. In fact, we can get quite a bit more complicated. We could have fractions, and we could have radicals. Same idea as when we differentiated them. You want to write them as x to some power first. So on the bottom of the fraction, negative exponent, radical means it's going to be the power of a half. So increase the power by 1, gives you a half. Divide by the new exponent, so divide by negative a half plus 1, which is a half. And if you divide by half, that's the same as times it by 2. And then like you did before, as the original question is in radical form, make sure your answer is also in radical form. So x to the power of a half, we can rewrite as radical x. Last skill we're going to look at for today's lesson is finding the equation of a function given its gradient and a point that it passes through. So gradient is like dy by dx. So if we want to find the equation of a function, we're looking for y. So to get from dy by dx to y, we're going backwards. So we're actually doing an integration question with 6x plus 1. So work out the integral of 6x plus 1. Don't forget to put the dx on the end to show that it's an integral. Work out what all these are. Now if you could do these in your head, that's great. If you can't, then just do the rule we just did. This is the power of 1. So increase the power by 1, divide by the new exponent, and 6 divided by 2 is 3. 1 is technically 1x to the 0, but we don't normally think of it like that. So if we increase the power by 1, divide by the new exponent, and then x to the 1 is just x. Probably easier to remember that for a number, the integral of a number is just that number of x's. So if it was 3, this would have been 3x. And then always don't forget to put the plus c on the end. But this time we can find out what c is. We're told what x is, and we're told what y is. So if we substitute those values into this formula, and then start to evaluate this, so 3 times 2 squared is 12, plus 2 is 14. Then we can solve for this equation for c. So c is going to equal negative 4, and then now we can plug this back into here to say what our equation is actually going to be. So 3x squared plus x minus 4. One other trick that sometimes they ask in questions, rather than giving you a specific point, they will say it passes through the origin. And the origin is this point on the graph here. So in other words, the coordinate is 0, 0. So keep an eye out for that question as well. And you should be ready now to try the questions from 16a.